All right, guys, we're looking at problem 415. Basically, what I did was started by drawing a diagram using the given information. So the first 1, 2, 3, or I guess 2.5 sentences are just describing the situation, and this is the situation. What they want you to do is find the measures of angles Q and R. So that's this guy right here and this guy right here. So one of the keys to this is that you have to be able to use the results from a different problem, and we'll get to that in a second, and that's really the important step here. So let's piece together some info that we know first, and then we'll talk about that. So first of all, what we know is that this angle, we can figure out these two angles just based on this triangle FPM. So I know that angle FMP is 72 degrees because of the triangle sum theorem. And then I can relate that angle with this angle, PMR, based on it being a linear pair. So that's kind of preliminary, hopefully nice, easy stuff. So what we need to do from there is we need to use a consequence from a previous problem, what we showed from a previous problem. And this problem is number 380 in your problem set, in a previous problem set. So what we figured out basically is if you have a right triangle, which this is, that's a right triangle. M is the midpoint, so we know that this guy is congruent to QM. So essentially what we figured out was that PM in this particular case has to be the same as RM, or congruent to RM in this particular case. So one more time, if you draw the midpoint of a right triangle and connect this vertex here to that midpoint, then that midpoint is going to be equidistant to each of the vertices. So QM, PM, RM, all congruent. And again, that's from problem 380, so go back and look at that one if you need to. So what that tells us for this problem is that this thing is isosceles. So we know that the vertex angle, this angle up at the top, is 108, and we can now piece together these two base angles based on kind of the definition of an isosceles triangle. So we subtract that, and then we chop it in half, and we'll get what's left over is going to be this angle and this angle. And what is left over is 72 divided by 2, so that's a 36 here and a 36 here. So we now know angle R, so the measure of angle R is 36 degrees. And we can now use that triangle sum theorem. And this is basically a definition of isosceles, or I guess isosceles triangle theorem, where the base angles are going to be congruent. And then the last one is angle Q, and this can be given by the triangle sum theorem. So we know that this angle P, the whole thing, QPR, is the right angle. We know that this guy's 36. So 180 minus 90 plus 36 is going to equal angle Q. That's just triangle sum theorem. And this will give you 126, so what's left over there looks like 54 degrees equals angle Q. And we're done.